Okay, so today we're going to start chapter 9, and chapter 9 is going to be all about circles and angles. And today we're going to talk about 9.1, which is circles and central angles. You're going to have a quiz in this chapter after section 4. The first part of this section is going to be a lot of definitions, and you're going to want to keep them handy and throughout the chapter so that you can always come back to them. Okay, so a circle. A circle is the set of points equidistant from a given point, which is the center. So if I put the center of the circle there, that's going to be my circle. A radius is a segment with endpoints at the center and on the circle. So again, if I want to draw a radius, that's a radius. It goes halfway across the circle. A chord is a segment with endpoints on the circle, but doesn't necessarily pass through the center of the circle. So if I just make two endpoints on the circle there and then connect them, that's a chord. Okay, a diameter is a special kind of chord, and the reason the diameter is special is because it's going to pass through the center of the circle. So again, if here's the center of the circle, and then I have two endpoints on the circle, that's going to be your diameter. Okay, and the diameter is going to equal 2 times the radius. So if you're given a radius and you were told that one part of the radius was 2 and you wanted to know what the entire diameter was, 2 plus 2 would end up being 4, or 2 times 2 is 4. A secant is a line that intersects the circle in exactly 2 places. So a secant, and a lot of times what it's going to look like in this picture is going to be, there's 2 secants here, but secants will look something like that. Again, if you just concentrate on one line, it touches that circle in 2 spots. Okay, a tangent line intersects the circle at exactly 1 point. So again, if I could draw 2 tangents to this circle here, touches once there. So that's 1 tangent, once there, that's another tangent. So there's 2 tangents in that picture now. The point of tangency is the point at which the tangent line intersects the circle. So again, if I draw 2 tangent lines, and we'll concentrate on this one, that's your point of tangency. A central angle. A central angle is an angle whose vertex is at the center and 2 sides are radii. Okay, so again, if I have my center of my circle here, and there's one radius and there's another radius, that angle right there becomes what's called a central angle. An inscribed angle is an angle with a vertex on the circle and 2 sides that are chords. So all I'm going to do is pull that vertex from above onto the side of the circle and draw an angle that intersects the side of the circle twice there. That's your inscribed angle. Okay, an arc is any part of a circle, and you use this little arc symbol to represent that. Okay, so if I want arc BC, that's arc BC right there. And to write that, you just put a little arc over the top of B and C. Okay, a minor arc is an arc with a measure that's less than 180 degrees, and you're only going to use 2 letters to name it. So remember, there's 360 degrees in a circle. So 180 is half of 360. So a minor arc has to go less than halfway around the circle. I'll use different letters. So I'm going to say arc CD. So when I say arc CD, I'm very specifically talking about one arc here. It's this arc. That's the arc that's less than 180. I could not say that purple arc was CD, because again, that goes more than halfway around the circle. That would not be a minor arc. Okay, a major arc is an arc that's greater than 180 degrees. And in this case, you're going to have to use 3 letters to name it. So if I stuck with that CD from the top, but now I wanted to talk about an arc that's bigger than 180. So in this case, I would say CED would be the major arc. Okay, a semicircle is half the circle, and it's always equal to 180 degrees. So again, depending on how you want to look at it, you can cut the circle right in half like that. You can highlight the half of it if you want. Okay, and then the thing that's going to come into play for today is that the central angle is always going to be equal to the measure of its intercepted arc. Okay, so the measure of the central angle, angle AOC, which is highlighted here in blue, is going to be equal to the intercepted arc. So what does that mean? If I told you that the measure of angle AOC was 30, that means the measure of that arc AC is also going to be 30. So the first thing that we're going to do is just name those parts of those circles. And again, if you want to try to pause it and name it before you come back and see my answers, that might be a good thing to do to try this on your own. But literally all we're going to do is use those vocabulary words from that first slide to answer these questions here. Okay, so it says use the diagram below along with the bank to classify each circle part. Parts may be used more than once. So the first thing that we want to look for is LQ. Okay, so LQ is this line right here. Okay, and LQ touches that circle in only one spot. So that means that LQ is a tangent. Okay, angle NQR. Angle N, let me use a different color so it pops out a little bit more. NQR is that angle right there. Okay, and that angle has its vertex point that lies on the circle. That means that this is going to be an inscribed angle. Okay, and again, now we have to be careful for number 5. So number 5, we have arc RWU. So we're using 3 letters to name that, which means it's going to be bigger than 180 degrees. So again, I'm going to find point R, then I'm going to go to W, then to U. Okay, so here's R, here's W, and here's U. So again, I'm going to connect them in that order. So R, W, U. That's bigger than 180 degrees. That's going to be a major arc. Okay, PN. PN is going to be this piece right here that I'm highlighting in green. That goes from the center of the circle to the circle itself. That's going to be a radius. Then I have MQ, and again, there's an arc symbol above it. So that's arc MQ right here. And arc MQ is less than 180 degrees. So that means that that's going to be a minor arc. And then I have point R. Point R right here. And again, I have this line that crosses through there. So that's going to be a point of tangency. So there's my point of tangency. Let me erase my pictures here, clear it up a little bit to make it a little bit clearer when we go back. And I'll do orange again. Okay, and now I have for 13, I have arc QRN. So again, we're going to go in that order, arc QRN. Okay, is that arc right there. And we just have to be careful here. That's technically not a major or a minor arc. Why? Because it's exactly half the circle. So that's going to be your semicircle. Okay, the next one I have is line segment WY. That does not pass through the center of the circle. So the only thing that's special about that, or the only thing special that we can call that, is a chord. Point X. Point X is right there, and that is going to be the center of your circle. Then I have line segment ST. I'll switch to red. So ST is this line segment right there. It touches both those circles at only one spot. And if it touches at only one spot, that's going to mean that it's a tangent. Next, I have angle UXY. So UXY is this angle right here that I highlighted in red that now has the red arc through it. Okay, and again, that vertex is in the center of the circle, which means that's a central angle. Line segment QN. QN goes right across the center of that circle in that left-hand circle, passes through the center. That means it's not only a chord, it's more special than that. It's going to be a diameter. Line segment UY. UY, change to green. UY is here. It intersects that circle at 1, 2 spots. That means that that's going to be a secant. Else if I spell it right. And then angle MPQ. MPQ, again, I'll highlight in green, is that angle right there. And again, that angle is, vertex is at the center of the circle. So again, that is going to be a central angle. Okay, so just some practice using that vocabulary there. Okay, and now we'll do some examples, again, related to the central angle. So again, just keep in mind that the measure of the central angle is equal to the intercepted arc. Okay, so the first thing I want to find is arc BC. Arc BC is right there. That's going to be equal to its central angle, which is the one that's labeled 32 there, which means that arc BC is going to be 32. For part B, we want to find BD. So BD is going to go from here to here. Okay, again, how did I know to go that way and not start at B, go to A, and then to D? Because I'm only using 2 letters, it has to be less than 180 degrees. So the angle that intercepts is going to be this angle here. Okay, well, I already know the red angle, so now if I know the one that I'm putting the smaller green arc through, if I know the measure of that angle, I can add them together to get the measure of the entire arc there. So that angle is going to be 58, or again, I had this 32 up there already. I could have just added those 2 together. 32 plus 58 is going to give you an answer of 90. So arc BD is going to be 90. Now we want ABC. Okay, so again, for ABC, I'll go to A, then to B, then to C. Again, that arc is going exactly halfway around that circle. Half of a circle is 180 degrees. Okay, and then the last thing that we need to find for this slide is AB. So AB is here. So we just talked about the fact that ABC is 180. And now I also know that this piece is 32. So if I take that 180 and get rid of the 32, I'll have 148 left for the rest of that arc. So arc AB is going to be 148. Okay, 2 more slides left. Okay, find each angle and arc measures in circle X. So the first thing that we need to find is angle UXV. So UXV is going to be this angle right here. Okay, and UXV, let's do this in kind of 2 steps. This arc over here is 72, which means that the intercepted angle here, the central angle, is going to be 72 as well. And now that angle that measures 72 and the other one that I have that purple arc through, which is what we're actually looking for, are vertical angles. And again, vertical angles are congruent. So that means that angle is also going to be 72. Okay, arc ST. Okay, so now we need to find arc ST. Well, if to find arc ST, wouldn't it be nice if I knew the angle in between here? And again, I can find that. How? All 3 of those angles have to add up to 180. So if I take 180 and get rid of the 87 and the 72 that I've used, that's going to leave me with 21, which means the angle there is going to be 21, which means that arc that it's intercepting, again, the central angle and its intercepted arc are congruent, is going to be 21 degrees. The measure of WV. WV is going to be, arc WV, change colors again. Arc WV is going to be this arc right here. Okay, and again, we already know from a previous part of the problem that that angle that I just wrote in green was 72. And these 2 angles, again, form a straight line. Okay, so again, if I can find this angle, it's going to be equal to this arc. So again, if I take my 180 and get rid of the 72 that I've already used for over here, that's going to leave me with 108, which means this angle is not 180, sorry, 108, which means also that its intercepted arc is 108 as well. So arc VW is going to be 108. TW, arc TW is going to go from here to here. And again, all I'm going to do is add the two arcs that make up that big arc together. I'm going to add the 72 plus the 21 together. And when you do that, you should get an answer of 93. So arc TW is going to be 93. And let's again change colors here. Okay, arc TVW. So again, I'm going to connect that arc in that order. So I'm going to go T to V to W. So really, the only part of the circle that I don't want is that green section that I had just found in the previous problem. So again, if there were a total of 360 degrees in that circle already, and again, we just found in the previous problem the measure of arc TW was 93. So if I get rid of the 93, that's going to leave me with a total of 267 degrees. And again, your answer makes sense because you have three letters. Your answer has to be bigger than 180, and mine is. Okay, and our last problem, we want to find the value or measure of each thing that it's asking us for here. So the first thing that we want to find is x. So right now I'm told that arc AD is 8x plus 12, and arc BC is 10x minus 22. Again, if I look at the arcs that those intercept, the angles that are intercepted by those arcs, it's going to be those two angles there, and those two angles are vertical angles. So since vertical angles are congruent, that means that both of these arcs are going to be congruent. So to solve for x, we're just going to take 8x plus 12 and set it equal to 10x minus 22. Again, doesn't matter how you solve here. I'll subtract 8x from both sides, and I'll have 12 equals 2x minus 22. Add 22 to both sides, and 34 is going to equal 2x. Divide both sides by 2, and x is going to equal 17. So for part A, x is going to equal 17. So for part B, we want to find the measure of arc AD. AD was the one represented by 8x plus 12. And again, we just found in the last problem that x was 17, so we're going to do 8 times 17 plus 12. 8 times 17 should give me an answer of 136, and when I tack on that other 12 to it, altogether that arc should be 148. Arc CD. CD is the small arc right here that I'm putting in purple. And again, if I look at this entire arc going from A to D to C, that would be half the circle. That would equal 180. So if I take the 180, and again, we already found AD in the last problem. If I get rid of that AD, if I get rid of that 148, that's going to leave me with arc CD, which is going to be 32. So arc CD is 32. Change colors one more time here. I don't want to erase some of the stuff in case we kind of need it in another part of the problem. BDC, arc BDC. So again, we're going to draw the arc in the order that the letters appear. So I have to go from B to D to C. Okay, so that's that green arc that I've highlighted. That's what I want to find the measure of. Well, the only part of the circle that's not included in that arc is the one that's represented by the 10x minus 22. I technically know what 10x minus 22 is. Again, in a previous problem in part B, we found that this arc over here was 148, which means that arc over here is also going to be 148. So if I take my 360 and subtract out 148, that will leave me with 212 for the rest of that green arc. The measure of angle AED. AED is this arc right here that now has the green arc through it. Again, if I go to the arc that intercepts, it's the one that was labeled 148. And again, a central angle and its intercepted arc are congruent. So the measure of angle AED is 148. And then the last one, I need to find the measure of angle AEB. AEB is this angle right here in orange now. So again, this entire angle is 180. It goes halfway around the circle. We already used 148 degrees. So if I take my 180 and subtract out 148, it's going to give me a measure of 180 minus 148, not 48. It's going to give me a measure of angle 32. So this will be 32 as well as the angle. Okay, or again, in the previous problem up here, we found that CD was 32. And again, CD and AB are also going to be congruent because they're intercepted by vertical angles there. So more than one way to find some of the answers to these problems. Okay, and that is it for this section.